Hi everyone, on this section we're going to be factoring trinomials, and I'm going to show you a few different methods. Now I just want to reassure you that if the third method turns out to be your favorite, you can use that on everything, but I would like you to learn that on this first type of trinomial there is a shortcut. So you're going to see that we kind of do some of the same things for each method. On this one, we are factoring trinomials where the leading coefficient is 1. So notice, right, I have an x squared, which is 1x squared. When that's the case, then I can just find factors of the c, right, factors of c, which is this number, and then I can write it in factored form. So the thing that I always know is that x squared is x times x. Now we're going to write this in factored form, and then you can always check your answers by multiplication to see if you get back the same trinomial you started with. Okay, so we're just going to look at factors of 20. Let me write that out better. Factors of 20 that have a sum of 9. Now we're going to use some of the same type of thing as we work through some of these other methods. So factors of 20, I think that most of you are going to think of the ones that we need right off the bat because it's probably maybe most common, right? 20 has several factors though, so I'm going to list these just to talk about it. 1 times 20, 2 times 10, 4 times 5. Okay, well, all of those are factors, but only one set gives us a sum of 9, and that would be 4 and 5, right? Because if I add those together, I get 9. So that is the two numbers I would need for my factors. And then this is factored. You can double check, right? Here's 4x and 5x. That equals 9x when I add them, right? And then 4 times 5 is 20. That's my constant term, and so we're good. Now, a lot of these will go pretty quickly because you don't have to do anything but consider the C term to figure out the two numbers you need for your factors, or to factor, I should say. Okay, let's look at this next one. It's still in the same form, right? 1x squared. So I'm going to take factors of negative 36. Now we have to talk about signs a little bit on this one, and then I need a sum of negative 9, right? Factors of negative 36 that have a sum of negative 9. Now 36 actually has lots of factors, so if I start listing those, because you know that we're going to factor, now I know that this is going to be x minus something and x plus something, because to get a negative 36, I have to multiply a negative and a positive. So we need to look at, oh, okay, my signs have to be different on these two. When I'm finding the sum, then I need to get a negative 9. So if we go through and list the factors of negative 36, I have negative 36 times 1. And the bigger number gets the negative here, right? Because when I add them, I need a negative sum. So negative 18 times 2, right? That doesn't give me a sum of negative 9 yet. And then negative 12 times 3. And I'm going to stop right there because that's actually the pair I need, because negative 12 plus 3 is negative 9, right? So this fits the criteria. When I multiply, I get negative 36. When I add, I get negative 9. And so I'm going to say 12 and 3. And then we have this thing factored. That's it, right? Double check yourself if you need to by multiplying your two binomials to see if you get x squared minus 9x minus 36. Okay, so let's look at this next one. So we're going to find factors of negative 54 that give me a sum of positive 3. So I know on this I need a negative product, right? When I multiply it has to be negative, so I know that I'm going to have x minus something and x plus something again, just like we did on that last problem. Okay, so if you start listing factors of negative 54, this time the larger one the larger number is going to be the positive one. So if I list, I'm going to list it this way. So I'm going to say negative 1 times 54. So the bigger number is going to be the positive one because I need a positive sum. Negative 2 times 27. Let's see, I think negative 3 times 18 is also a factor. And then we're going to jump to 6 and 9. Okay, so it's going to be a negative 6 times a positive 9. And that's the one that gives me the correct sum, right? So here's, I've found what I need, and it's a negative 6 and positive 9. Now, as you're working through the factors, you can use your calculator, and you can see that most of the time you're going to be able to find them pretty easily as you work your way through. 6 and 9 is probably the more common one that you might recognize for 54 if hopefully you know your times tables, because that does definitely help a lot. Okay, next. Okay, so on this one, my signs, the way the signs are laid out here means I need a positive 27 when I multiply and a negative 12 for my sum. Right, so I multiply to get a positive 27, I add to get negative 12. What that's telling me is my signs have to be the same thing, right? Because a negative times a negative is a positive, or a positive times a positive is positive. In this case, both signs have to be negative. That's the only way that I'm going to get a positive product and a negative sum. Okay, so if I list factors of 27, that would be negative 1 and negative 27, negative 3 and negative 9. I believe that's it. That's all the factors that we might be able to find, but negative 3 plus negative 9, that's the ones I need. So this time it's going to be minus 3 and minus 9. So my factors have the same sign this time, or my constant part of this, the negative 3 and the negative 9. Once again, you can go through the checking by multiplying to see what you get there. Okay, next. This is all positive. That's always the easier one. So I need a product of 8 and a sum of 5. Right, so you know that I'm getting the 8 from here and the 5 from there, right? I have to get a sum that equals that middle term. And I know it's x squared, so it's going to be x plus something, right? X times x is x squared, and then I'm going to add whatever my factors happen to be. So 8 only has a couple of choices, 1 times 8 and 2 times 4. 1 plus 8 is 9, 2 plus 4 is 6, and so we actually don't have any factors here that work. Now, I think that back, let's see, did it say back? No, it didn't say that on that chart. So if we can't factor something, right, it's not possible to factor this one, so we are going to say this trinomial is prime, and that means that the trinomial does not factor. And so that's what we call it, prime. Okay, so that was the first method had to do with my leading when my leading coefficient is 1, so I had a 1x squared. Now my leading coefficient is not 1. And this method, you can use this method for any trinomial, but I'm going to just say, let's use this method when the leading coefficient is a prime number or a number that doesn't have too many factors. You can make that decision, but if it's prime, that's helpful because prime numbers only have the number itself and 1, you know, like 3, right? 3x squared. 1 times 3 is 3. That's the only two factors I will have. So I don't have as many to try, because notice this one says trial and check. So what that means is we're going to try to come up with the factors that are going to work for this in such a way where we're checking them to see. Okay, so here's what we do. Write all the pairs of factors of ax squared. Okay, so let's just start out 3x squared, and we already discovered that it's going to be, oh, let me write it this way, 3x times 1x. And that's it for that one. Then write all the pairs of factors of c, the constant term. So in this case, c is 4, and 4 would be 1 times 4 or 2 times 2. Okay, so those are the factors that we would have to try. Now it says try various combinations of these factors until the correct middle term is found. If no combination exists, the polynomial is prime. I knew it said that somewhere, that's why I was looking on the previous question. So the same thing could happen on this. If we can't factor it, we say prime, but you guys don't give up too quickly. You don't want to say prime just because you didn't find them. Make sure you've checked everything. Okay? All right, so here's what we do. We're going to just check. So we have a 3x and an x. We know that works, right? And so I like to try the ones that are closer together a lot of times because I feel like that may be the ones that work. But I'm going to go ahead and try the 1 and the 4. I'm going to say plus 1 and plus 4. Now you guys, I had two choices there. I could put the 4 here or here. And same thing with the 1. And so where you place the numbers matters also, because when you're checking to see, hey, can I get an 8x, right? That's what I'm trying to see here. So let's check this. We have a 1x and we have a 12x, and you guys see that doesn't work, right? Because we need a total. When we add that, it needs to be 8x, and this would equal 13x. If we placed the 4 in the first binomial and the 1 in the second binomial, then we would have a 4x and a 3x. 3x plus 4x is 7x, so you see that one doesn't work. And then the only other thing we have to check are 2's, right? Because that's it. So now I will tell you that if you actually practice this method, you may find that that's an x, not a 3x, plus 2. You may find that you can go through it quicker and you don't have to check as many things because you'll kind of start catching on to what to look for. And so notice on this one, I have a 2x here, and I have a 6x. 2x plus 6x is 8x, so I have found my factors. Right, so this is it in factored form. And we can see 3x times 3x, we already knew that. 3x times 3x, 3x times x is 3x squared. Geez, I keep saying that. 2 times 2 is 4. We already knew those two parts were going to work. It's just finding that middle term and making sure that it actually equals exactly what's there, which was 8x. All right, so I feel like I need to stop this video here because we're already at 13 something on the minutes, and then we will practice this method a few more times before we get to the last method. So this is the second way of factoring that I'm showing you. Okay, I'll see you on the next video.